Welcome back. So we finally made it to the end of this long chapter, and we're gonna end it up by connecting the chemistry that you have learned to a concept in biology mostly. And this concept is gonna be osmosis. What the definition of osmosis tells us is that it's the movement of solvent, so we're talking about mixtures, from low concentration to high concentration. And the reason the solvent moves from low concentration to high concentration is to dilute the high concentration while making the low concentration higher in concentration, therefore equalizing both of them and making it the same. This is a very important process because this is how cells in our body let nutrients in and out. Is part of the equation for doing that by moving from high concentration to low concentration throughout the cell membrane. It's just one of the ways that cells do that. So let's fine-tune this concept by doing this problem. So summarize and explain the process of osmosis. We just did that. However, we are now going to show it using this figure. So we're going to show the way the solvent is moving, left to right or right to left. And we are going to indicate is there any changes in the volume. So the volume of this chamber is there, and the volume of this chamber is there. So they're starting with equal volume, but osmosis is not trying to equalize the volume. Osmosis is trying to equalize the concentration. So remember, the solvent is always the one on the higher quantity. The solute is the one on the lower quantity. And when we look at this picture, we will see that the water molecules are going to be on higher quantity, and you can count them. And the solute particles are going to be the ones on the lower quantity. So the one with a higher percentage of solute to solvent is going to be the one with the higher concentration. And we're going to see that that's going to be chamber number 1. And chamber number 2 is going to be the one that have more solvent, so lower concentration. So osmosis is the movement of solvent from low concentration to high concentration, so it will dilute the higher concentration, making it the same as the low concentration. So to do that, water molecules will have to move across the membrane until the percentage of solute to water molecules becomes the same. Since we're moving water molecules to the left, the volume on the left is supposed to increase. And since we're losing water molecules from the right side, the volume on the right will have to decrease. So by the time you finish, you should have equal percentage of solute to solvent molecules on the left as you have on the right. And that's how osmosis works. So with that in mind, see if you can do that with on problem A and problem B. So you're doing 2 different problems. Basically do the same thing I just did on A and on B. And once we do that, we can call this concept covered and understood. If not, make sure you always go back to the textbook and read so you can get more context around these concepts. And once you do that, we can close this chapter. So at this point, you should be very proficient on knowing that a solution is a homogeneous mixture where you have 2 components at least. One of them is the one on the highest quantity, the solvent. The solute is the one that you dissolve. because they are moving faster and they can escape easier. And we saw how we can calculate mass percentage, which is the amount, the mass of the solute divided by the mass of the solute and the solvent. And we saw that this is just a conversion factor that you can use for calculations. The same with molarity, but molarity is going to be the moles of the solute by the total liters of the solution. And it's also a conversion factor which you can use on calculations. We saw the formula N1B1 equals N2B2 that allows you to calculate how to dilute a solution, and I showed you how to use this formula to know how to prepare a diluted solution in the lab. And we also saw that we can use molarity to find the number of moles of a given solute in a solution, and then we can use that in chemical reactions to do stoichiometry, mole-to-mole ratio problems. And then we went into a new type of concentration, molality, which is the moles of the solute by kilograms of the solvent. This is the only one that is kind of different. And we saw how by adding a solute to a solvent changes the properties of the solvent, and we study that the freezing point of the solvent will become lower, so water will no longer freeze at zero, it will freeze below zero if you add, for example, sodium chloride. And we also saw that the boiling point will be higher, which is why we put ethylene glycol in water, and we use coolant in our car to make sure that it doesn't boil at 100, but a lot higher than 100 degrees. And we finish up by going over osmosis. So with that said, we finished this chapter. We have one more chapter before we finish the course. So let me know if you have any questions or concern. You can always reach me through my email or through Canvas. So take care. Have a wonderful week.